Okay, this problem says suppose a coil has a self-inductance of 20 Henry and a resistance of 200 ohms. What capacitance and resistance must be connected in series with the coil to produce a circuit that has a resonant frequency of 100 Hz and a Q of 10. Alright, so we want resonant frequency of 100 Hz. So what we want is omega to be 1 over LC 2 pi f equal to square root of LC f equal to 1 over 2 pi LC, and f is given to be 100 Hz. We also want the quality factor, which is given by omega naught, the resonance frequency L divided by R. So you can see that this equation, since we know what we want for the resonant frequency, we know L, so this tells us what the value of the resistance should be in the circuit. And okay, so this would be the total resistance, and part of the resistance is in the inductor coil, so we'll come to that in a second. Okay, so let's calculate for that. R is omega naught L by Q. So R in the circuit is 2 pi F, which is 100 Hz. L is 20 Henries, and we want a quality factor of 10. So this tells us R in the circuit should be, so what does this work out to? That's 10, 200, 400 pi. Yeah, that's right. 10, 200 ohms. So (1,256.6 ohms). So since this is the net resistance in the circuit, okay, so what we want is and the inductor has a resistance as well, so R net equal to R plus the resistance of the inductor. So the R should be R net minus RL, and so the additional resistance we need to connect is given by R net minus RL equal to 1256.6 minus 200 equal to 1056.6 ohms. So roughly 1,000 ohms. A kilo ohm resistor is what we need to connect. All right, and then now we'll calculate the value of the capacitance. Okay, so F is equal to 1 over 2 pi LC. So actually it's a 4 pi square F square equal to 1 over LC. And the value of the capacitance in this circuit needs to be okay, so let's plug in numbers. 4 pi square The resonant frequency is 100 hertz square, and L is 20 henries, correct? Yep. So the value of the capacitance. So this is 10 to the 4, 10 to the 5. We'll bring that up. So that's 10 to the minus 5. And this is a capacitor, so it'll work out in farads. 4, 5. So we have 2 left, 8 pi squared. Okay, so this would be we'll write it as microfarads. Okay, 10 divided by 0.127 into 10 minus 6 farads. So the capacitor we need to connect is 0.127 microfarads for the resonant frequency to be 100 hertz. Okay, that finishes this problem.